Good morning, students. As you know that there is some technical issue. Yesterday was solved, only few questions. Today I will continue the remaining questions. That is, I think question number 11 is completed. Now today I will start 12th question and 13th questions of exercise 9.1. After that, I will explain Fibonacci sequence and it's complete the first exercise 9.1. After that, I will go for the detailed study of arithmetic progression. So we go to the 12th question. An equal to an minus 1 by n. Already your condition is same. Write the first 5 terms. As you know already, many example I was solved first 5 terms. It means I am taking n equal to here. They are given the question n equal to n is always greater than or equal to 2 means it has some condition. The given condition is what means here a1 equal to they are given a1 equal to minus 1. Okay. And the next n equal to n minus 1 divided by n. They are always you take n is greater than or equal to 2. Okay. N is greater than or equal to 2 means already we know the value of a1 first term. So that's why we take n equal to 2, 3, 4 and 5. We get second term, third term, fourth term and fifth term value. So I am taking first n equal to 1 here implies a 1 equal to a first term. Already given a first term. So I am taking directly n equal to 2. A second term is equal to a2 minus 1 divided by in place of n you take 2 divided by n. N means what? 2. I am taking 2 here. Here a 2 minus 1 it means it is a first term divided by 2 equal to already given that a first 1 is equal to minus 1. It means the first term value is equal to minus 1 divided by 2. It is the first term, it is the second term value and first term value is given. I am taking n equal to 3 here. Put in place of n, it is 3. A3 equal to, in place of n I am taking 3 here. A3 minus 1 divided by, again it is 3 in place of n. Now a3 minus 1 is a second term divided by 3. What is the a second term? It means second term is equal to minus 1 by 2 divided by 3 divided by 3 as it is. It shows that these two denominator is the multiple terms. It means 2 into 3. Nothing means here 1. So 1 into minus 1 is minus 1 divided by 2 into 3 is 6. It means the third term value is minus 1 by 6. Now next, take n equal to 4 here implies a fourth term is equal to a 4 minus 1 here. 4 minus 1 in place of n I am taking 4 here divided by 4 equal to a4 minus 1 means a3. It means the third term divided by 4. Third term is what? A third term is equal to minus 1 by 6. I am taking a third value is minus 1 by 6 divided by 4 as it is. Again same, the minus 1 as it is 6 into 4 is 24. It means the fourth term value is minus 1 by 24. And the last one, take n equal to 5 implies a fifth term equal to a5 minus 1. A5 minus 1 divided by in place of n again I am taking 5. Here a5 minus 1 means a fourth term divided by 5. A fourth term value is minus 1 by 24. I am taking in place of a4 it is minus 1 divided by 24 divided by 5. It is equal to, I will write one step extra. 24 into 5 equal to, here 5 into 4 is 20 minus 1 divided by 22 left, 5 to the 10 plus 2 is 12. It means minus 1 by 20 is the fifth term value. It means our required terms are, already first term is given, second term is minus 1 by 2, and third term is minus 1 by 6, and fourth term is minus 1 by 24, and fifth term is minus 1 by 120. Therefore, required first five terms, I will write here, required first five terms are, first term is given, it is minus 1, and the second term is minus 1 by 2. Next, the third term is minus 1 by 6, and fourth term is minus 1 by 24, and the last term is minus 120. Last means it is the fifth term value. It is the required first five terms. And also we write its sum of series. It means I also write corresponding series. It means I am taking minus 1 as it is. Corresponding series means the definition of series says that sum of the terms of a sequences is called series. It means you can take sequences part as it is, in between plus. That plus is called sum. The sum of terms is called, it is a series. Therefore, I am taking here minus 1 by 2 in the bracket. Next term is minus 1 by 6 plus minus 1 by 24 plus minus 1 by 120 plus so on. So this shows that corresponding value of the series. We go for next 13th question. Question number 13 is, here already given two terms value. It is a first term value, it is second term value is equal to 2. It means the value of A1 and A2 is equal to 2. We have to find next, take n is either greater than or equal to 2. It is not a accurate condition. N is greater than 2 is the correct condition, I think. It means I am taking n equal to 3, 4 and 5. Put n equal to 3 first. Already we know the first value, first term value and second term value. We have to find directly third term value. Here third term is equal to, here given condition is an equal to an minus 1 is there. In place of n, I am taking 3. A 3 minus 1 term is equal to, here A 3 minus 1 is A2 minus 1 is equal to, A second term value is 2 minus 1 equal to 2 minus 1 is 1. It means A third term value is 1. And I am taking next n equal to 4 implies A fourth term is equal to, in place of n I am taking 4 minus 1 equal to A third minus 1. It means third term minus 1 is equal to, A third value already we know, it is the A third value. A third means the third term value is equal to 1. So A3 value is 1 minus 1 is equal to 0. It means fourth term value is 0. And last one, n equal to, I am taking 5. Here n equal to 5, a5 is equal to a5 minus 1 minus 1 minus 1 as it is. So a5 minus 1 means a4. It means it is the fourth term minus 1 equal to. Already we know the value of a4. A fourth term is, it means the fourth term is 0. I am taking 0 minus 1. It is equal to minus 1. Hence, our required terms are already known value a1 and a2 is equal to 2. And the third term is minus 1, fourth term is 0, and fifth term is minus 1. I will write as it is sequence as well as series here. Therefore required first five terms are, two terms are given 2, 2, and the third term is 1, fourth term is 0, and fifth term is minus 1 is the required first five terms of sequences. And same corresponding series is takes in between sum 2 plus again 2, and the third one is 1 plus fourth term is 0 plus, and take in between a2 is there, take inside the bracket minus 1 plus so on. So it is the required first five terms of sequences as well as series. Okay, we go to last question. It is based on Fibonacci sequence. Before going to this problem, I will explain what is the Fibonacci sequence. See here, Fibonacci sequence. Fibonacci sequence. Here, Fibonacci sequence is a special type of sequence. It shows that always the sequence term start with 0 and 1. I am taking comma here. Always the sequence start with 0 and 1, and next number is sum of previous two terms. Sum of previous two terms. It means I will write here. See here, the next term value is sum of these two terms value is the next term. It means each term is equal to its sum of its previous two terms. I will take its condition. An is equal to an minus 1 plus an minus 2. Always n is greater than or equal to 2. This condition satisfies the Fibonacci sequence. It means, see here, add these two terms. Here 0 plus 1 is equal to, it means I am taking here n equal to 0. Okay, so I will put in the condition a in place of n I am taking 0 equal to, or already condition says that n is greater than or equal to 2. That's why I am taking directly n is equal to 2. already known value 0 and 1. Always Fibonacci sequence start with 0 and 1. That's why I am taking n equal to 2 directly. A 2 term, it means the second term. It means it is the initial stage called A naught term, and it is the first term value A1. We want to find A second term equal to how much? So A second term, in place of n I am taking 2 here. Again it is in place of n I am taking 2 minus 1 plus 2 minus 2. It shows that A2 minus 1 is, it is A1, and 2 minus 2 it is A0. See here, the value of A1 is 1 and the value of A0 is 0. It means, I will write here, the value of A1 is 1 plus value of A0 is 0. It is equal to 1. It means the next term value is 1. Again I am taking n equal to 3 implies, apply here n equal to 3. A third term value is equal to A 3 minus 1 plus 3 minus 2. 3 minus 2 term equal to A third term value is equal to A2 plus A1. It shows that A3 term is equal to, already we know the value of A2. We want to find A3 value here. It means sum of A2 plus A1 term value. So A2 value is 1 and A1 value is also 1. It means A3 value, it means third term value is 2. Therefore, it is 2. And next, sum of these two is, I will write directly, sum of these two, 1 plus 2 is 3. Again, 2 plus 3 is 5. Again, 5 plus 3 is 8, and so on. So, this type of procedure, this type of rule is called Fibonacci sequence. I will define here. Here, I will define sum of each term of sequence. Each term of sequence is equal to sum of its previous two terms is called Fibonacci sequence. I hope that you have understood this one. I repeat once again. Here Fibonacci sequence means it is a special type of sequence. Each term of sequence is equal to, here I write this condition, each term of sequence is equal to sum of its previous two terms, an minus 1, an minus 2. So always it satisfies this condition means it is called Fibonacci sequence. Here I am taking an example. Always Fibonacci sequence start with 0 and 1. It is the condition. What condition? Fibonacci condition says that always it starts from 0 and 1. And the next term value is equal to sum of previous two terms value. Therefore, the second term value is equal to sum of previous two terms. 0 plus 1 is equal to 1. It means it is equal to next term value. And again, 1 plus 1 is equal to 2. It is equal to third term value. And fourth term value is its previous sum of previous two terms. 1 plus 2 is equal to 3. And 2 plus 3 is equal to 5. And 3 plus 5 is equal to 8, and so on. It means it is third term, it is the fourth term, it is the fifth term, and it is the sixth term, and so on up to nth term value. And in generally, we can write the Fibonacci sequence an equal to an minus 1 plus an minus 2. Always n is greater than 2. Greater than or equal to 2. It satisfies the Fibonacci sequence condition. So based on this Fibonacci sequence, I will take one example. I think it is question number 14 in exercise 9.1. Last question it is. I will write question here. Question is the Fibonacci sequence. The Fibonacci sequence is defined by a1 equal to a2 equal to 1. It is the condition of Fibonacci, and they are given condition an equal to an minus 2 plus an minus 1 plus an minus 2, and n is always greater than 2. Then find, I will write here, then find the value of an plus 1 divided by an for n equal to 1, 2, 3, 4, and 5. It is the special type of sequence, and each term is equal to sum of its previous two terms is called Fibonacci sequence. Here, I will write given term as it is. Given the first term and second term is equal to what? 1. Not necessary to find first and second term value. So we have to find the next third term, fourth term, fifth term, and even sixth term also. Why means n equal to, we can take up to 5, means put here 5. 5 plus 1 is 6. We have to find up to sixth term value by using this condition. The given condition is what? An is equal to an minus 1 plus an minus 2, and n is, we take n value is greater than 2 always. Here I am taking n is equal to 3. a1 and a2 value is known. I am taking n equal to 3 implies a third term. In place of n I am taking 3. A third minus 1. a3 minus 1. a3 minus 2 is equal to it is a2 plus a1, and it is equal to already known value of a2 and a1. Both value is 1 and 1. So in place of a2 it is 1. In place of a1 again it is 1. It is equal to 2. Okay. And n equal to take 4 implies a fourth term equal to a4 minus 1 plus a4 minus 2 equal to, here 4 minus 1 is 3, a third plus a second term. So already we solved a third term value is 2, take a3 value is 2 plus a2 value is already given 1 it is. So a2 value is 1. Therefore, it is 3. Next, take n equal to 5 implies a fifth term is equal to a 5 minus 1 plus a 5 minus 2 equal to a 5 minus 1 is a fourth term, and a 5 minus 2 means a third term equal to here a fourth term value is 3 and a third, it means third term value is 2. Here 3 plus 2 is equal to 5. But we need to find a6 value also, since our condition is what? Find an plus 1 divided by an, means if you put n equal to 5 here, so 5 plus 1 is a6. It means we need sixth term value also. So that's why I'm taking here n equal to 6 implies a sixth value. It means a6 means sixth term value is equal to a6 minus 1 plus a6 minus 2 is equal to, in place of n I am taking 6. Okay, so a fifth term, 6 minus 1 is 5. So a5 minus a5 plus a4. Here fifth term value is 5 and fourth term value is 3. Therefore 5 plus 3 is equal to 8. So these values are the term of third term, fourth term, fifth term, sixth term values are 2, 3, 5, 8. Now we have to find the given condition an plus 1 divided by an by using n equal to 1, 2, 3, 4, 5. Put n equal to, I am taking here first given condition, given an equal to, I will write here, an plus 1 divided by n, put n equal to 1 implies here a1 plus 1 divided by, in place of n I am taking 1. So a1 it is a1 it is equal to a second term divided by a first. It means second term divided by first term. It is equal to, already these two values are given. a2 is equal to 1 and a1 is equal to also 1. So in place of a2 I am taking 1 and a1 again it is 1. 1 divided by 1 is 1. It means the first value is 1. I am taking next n is equal to 2. Here 1 is completed. And next is what? For n equal to 2, the value is what? I am taking n equal to 2. Apply here given condition. Given condition a2 plus 1 divided by, here I am taking an here. It is an. Given condition an plus 1 divided by an plus 1 divided by an is the given condition, divided by a2 equal to 2 plus 1 means third term divided by second term value. Here the third term value is 2 and the second term value is 1. Therefore it is third term value, it is 2 divided by 1. Okay, next it is equal to 2 and next I am taking n equal to 3 implies, apply here n equal to 3, a3 plus 1 divided by, again here n equal to 3, a3 equal to a4. It means the fourth term divided by third term, it is equal to, here fourth term value is 5, here fourth term value is 3 and the third term value is 2. It means fourth term value is 3 and third term value is 2. It means the if you put n equal to 3, you will get 3 by 2 is the result. And next I am taking 2 is completed, 3 is completed. Next I am taking n equal to 4. Take n equal to 4, apply in the given condition. 4 plus 1 is 5 and here a fourth term. It means a fifth by a fourth term. A 4 plus 1 divided by a4. It is equal to a fifth term divided by a fourth term equal to Already we know the value of A5 is equal to 5 and A4 is equal to 3. Therefore, it is 5 divided by 3. And the last I am taking n equal to 5 here. Take n equal to 5. Apply in the given condition. A5 plus 1 divided by A5 equal to A5 plus 1 is 6. A sixth term divided by fifth term. Therefore, the sixth term value here, the sixth term value is 8 and fifth term value is 5. Apply here, it is 8 divided by 5. Therefore, required terms are, I will write here, the required terms are 1, it is the first one. If you put n equal to 1, you will get 1. N equal to 2, you will get 2. Next, put n equal to 3, you will get 3 by 2. Next, put n equal to 4, you will get 5 by 3. And last one is 8 by 5 is the our required term by using Fibonacci sequence. Up to this, the first exercise 9.1 and based on few examples I was completed. Next, we go to the standard process arithmetic progression. I will start now. Arithmetic progression. In the short form, it is called AP. You are already studied in the class 10th as arithmetic progression. Already you know the value and its term, its formula, but I am explain once again. Okay. And arithmetic progression is also called, I will write in the bracket, arithmetic sequence. Both are same. Sequence. Here progression means we have to calculate nth term value called progression. Mathematically we can calculate nth term value is called progression or as well as sequence. Both are same. So here the actual definition of arithmetic progression is, I will write in the short form, AP is it is a special type of sequences. It follows the difference rule. It means the consecutive sum of consecutive terms is always constant. Then it follows a particular rule. That particular rule is called a difference rule. That is, sum of consecutive term is always equal to constant. I will write here, arithmetic progression is a sequences of a numbers such that the difference between consecutive terms is constant. That is, I will write here condition, that is, here an plus 1 minus anth term is always equal to constant. Is always equal to constant, then it is said to be what? Arithmetic progression. I repeat once again, arithmetic progression is a special type of sequence. It follows a particular rule. It follows a definite order. That is, it is a sequence of a numbers. I will take numbers here. 1, 3, 5, 7, 9, so on. So whether it is a sequence or not, yes, by the definition of sequence, it says that an arrangement of numbers in a particular order or definite order, then it is said to be a sequence. The taken example is a sequence. Here, I will take the given condition here. An plus 1 minus an is equal to constant. I will take here as it is. Put n equal to 1 here. Otherwise, I will write here the condition, that is, the condition is an plus 1 minus an is equal to always constant. Constant. I am taking one example, 1, 3, 5, 7, so on. Here I am taking n equal to suppose 1. Suppose its condition always state that I am taking n equal to 2. It is the term of A1, it is the term of A2, it is A3, it is A4, and so on. I will take n equal to 1 first. Implies A, in place of 1, I am taking 1 plus 1 minus A1 is equal to. Here, 1 plus 1 is 2. A second term minus A first term is equal to. Here, see, the A second term is 3. It means the second term is 3 and minus first term is 1. 3 minus 1 is 2. And I am taking n equal to 2 implies A2 plus 1 minus A2 is equal to. In place of n, I am taking 2 here. A third term minus A second term is equal to. Here A third term is 5, A second term is 3. Again it is 5 minus 3 is equal to same constant number 2. I will take one more term, n equal to 3, implies, put the given condition, A 3 plus 1 minus A3 is equal to. 3 plus 1 means it is A fourth term minus A third term equal to. Here fourth term value is 7 and third term value is 5. Again it is 7 minus 5. It shows same constant 2. It means these all numbers are called constant numbers. In between these two and these two consecutive numbers always have same constant. The difference between two consecutive numbers have same constant means it is called arithmetic progression or arithmetic sequence. Okay, here up to nth term I am taking a nth term, it is A1, A2, A3, A4 up to so on, it is AN, and here the first term is called A, and difference between these two is 2, therefore second term is called A plus D. It means you can take difference between these two consecutive number is 2 and first term is 1. The sum of 1 plus 2 is 3. And next value is A plus 2D. And next this value is A plus 3D up to so on. And the last term we don't know, that is called A into n minus 1 into D. It is the last term value. So that's why I am taking here an the term is equal to the formula a nth term is equal to a plus n minus 1 into d. By using this condition, we have to find total terms value or number of terms value or first term value or difference between two consecutive terms value. Here a is called first term value, first term of a sequences, and n is called number of terms of a sequences, and an is called nth term of a sequences, and d is called common difference between sequences terms, common difference of a sequences. So it is the general formula of arithmetic progression or arithmetic sequences. Or here it is first term is called a, second term is called a plus d, third term is called a plus 2d, and so on. Last term is called a plus n minus 1d. Or also we take here in place of a plus n minus 1 into d, also it is called last term, read it as small l. It shows that also small l is equal to, we can take a plus n minus 1 into d. Both are same. And similarly I will write here the sum of terms. We calculate the sum of terms is Sn is equal to n by 2 into 2a plus n minus 1 into d. It shows that it gives a sum result of a series. And also it can be written as sum of terms is equal to n by 2. Here 2a can be written as a plus a. It is equal to 2a plus n minus 1 into d. And again I know that L is equal to a plus n minus 1 into d. I am using here, it becomes sum of terms is equal to n by 2, a as it is plus L. So both are same formula to find sum to nth term of the series. So I repeat once again, arithmetic progression is a sequences of a numbers such that it is a consecutive difference between consecutive terms is always constant, is called arithmetic progression. That is, I am taking the condition here, an plus 1 minus an is always equal to constant. See here, the constant term, it is always same, always second term minus first term. Here second term is, I am taking here 1, 3 minus 2 is 2, 5 minus 3 is 2, 7 minus 5 is 2. So always consecutive term, the difference between consecutive term always constant, then it is called arithmetic progression. And also this constant term is read as d, common difference, also same as this constant term. Dear students, if you have any doubts, write in the chat box. Chat box will open now. Here, one of the student asking the doubt is the question number 12 on exercise 9.1. Here, find the first five terms and their corresponding series of an equal to, they are given condition an equal to an minus 1 divided by n, as well as they are given first term value is minus 1. So, and they are given condition n is greater than or equal to 2 means already they are given a1, it means the first term value is equal to minus 1. We have to take n equal to 2, 3, 4, 5. It gives the total 5 terms values. Here I am taking first given term as it is. A n term is equal to an minus 1 divided by n. Already we know the value of first term minus 1. I am taking directly n equal to 2 implies here second term is equal to, in place of n I am taking 2 here. Here 2 minus 1 divided by 2 equal to, here 2 minus 1 means it is the first term divided by 2. Already we know the value of first term a1 is equal to minus 1 divided by 2. Therefore, the required second term value is minus 1 by 2. And similarly, I am taking n equal to 3, it gives third term value. Here, in place of n, I am taking 3 minus 1 divided by 3. It means 3 minus 1 means a second. It means second term divided by 3, and it is equal to, already we know the value of second term value. Second term value is what? Minus 1 by 2. Minus 1 divided by 2. And divide by 3 is there. Take divided by 3. Here, nothing means 3 dividing by 1. Or you can write directly divided by 3 as it is. And I will write one more step, minus 1 by 2 into 3. 1 by 3. It is equal to 1 by 3. Therefore, it is equal to minus 1 by 6. It is the required term of, required third term value is minus 1 by 6. Similarly, I am taking n equal to 4, implies a fourth term equal to a4 minus 1 divided by n equal to 4 is there. I am taking 4 here. Here, third term divided by 4. Third term value is minus 1 by 6 divided by 4, 4. Here, 4 into 6 is 24. Therefore, it is minus 1 by 24 is the value of fourth term. And last one I am taking n equal to 5 implies a fifth term is equal to a5 minus 1 divided by 5. In place of n, I am taking 5, 5. Therefore, 5 minus 1 it gives fourth term divided by 5. Again, I am using fourth term value. Here, fourth term value is minus 1 by 24 divided by 5 as it is. Here, 24 into 5. I am multiplying 20 into 5 is 100 and 4 into 5 is 20. 100 plus 20 is minus 120 is the fifth term value. And I will write here required condition. Required condition is what? Required first 5 terms is. Required first 5 terms. 5 terms are, so first one is given minus 1, comma, second one is minus 1 by 2, and third term is minus 1 by 6, fourth term is minus 1 by 24, and the last term value is minus 1 divided by 120 is the required terms of sequences. As well as we have to write corresponding series. It means the sum of terms of sequences is called series. Therefore, I am taking in between plus minus 1. I am taking in the bracket. Since negative sign is there, that's why I am taking inside the bracket. Sum. It means plus minus 1 by 2 plus minus 1 by 6 plus minus 1 by 24 plus minus 1 by 120 plus 3 dots indicates that it's continued terms.
Yes.
One student doubt is what is Fibonacci sequence, right? Suppose a given sequence is like this. Suppose a given sequence is 1, 1, 2, 3, 5, 8. If these types of sequences there means, if we add first two term, we will get third term. Okay. If we add first, second and third term is equal to 4, right? If we add 3 and 4, we will get fifth one, right? If we are adding uh, next terms, then we will get 8, right? So what is Fibonacci sequence is A3 or A1. Here in this sequence, A1 is equal to A2, right? A1 is equal to A2 is equal to 1, right? Then what is A3? A3 is nothing but this one, right? 2. So A1 plus A2, sum of before two terms, right? Writing these types of sequence is called Fibonacci sequence, right? General form of this Fibonacci sequence is an is equal to an minus 2 plus an minus 1. Here remember one thing. What is that? Condition should be n is greater than 2. Right? If n is equal to 2 means here we will get 0. Right? 0 is not there. First starting is 1. Right? That's why if we are adding first two term, we will get next one. This type of sequence is called Fibonacci sequence. Is it clear? Okay, thank you.
Next.
Time 1 hour ತೋರಿಸುತ್ತದೆ, 1 hour 10 minutes ಅಲ್ಲ ಸರ್? ಅದು ಓವರ್ ಸರ್?
Yes, ma'am. Time setting.